So if we wanted to find the resonance structures of this compound, what would we do? So we can move this double bond right here and then get rid of that plus charge. And so a general trend is that whenever you see a plus charge and you see a double bond, you usually move that double bond towards that plus charge. And that's what I did. Right here, I moved that double bond here, therefore get rid of the plus charge, and then giving a plus charge here. Because you have to understand, when you move an electron, right, you're not adding anything, you're actually decreasing it. Therefore, you get a plus charge. Now that's very hard to see, so therefore I drew out all the carbons and hydrogens. Now it should be easier to see what's actually happening. So if we calculate the formal charge of this carbon before we give it the double bond here, we'll see that it's a plus charge, because to calculate the formal charge, we count up the lone pairs and bonds, right? So if we count up the bonds, it'll be 1, 2, 3, and for carbon, you actually need 4, right? So it's in group 4, so it requires 4. And right now we only have 3, so 4 minus 3 will give it a plus charge. However, over here we have 1, 2, 3, 4, right? So 4 minus 4 will be 0. So therefore this has a 0 formal charge. So when we move that double bond, right, when we move it over here, we'll get 1, 2, 3, 4. Therefore 4 minus 4 is 0, so it's 0 charge on carbon. But over here, it'll be 1, 2, 3, right? So 4 minus 3 is plus 1. And that's why we have a plus charge over here and then a plus charge here. Because when we move it, this will get a plus charge. But let's say if we moved it back, then this would get a plus charge. So I hope that helped, and thanks for watching.